So in the last video, we talked about calculating density when mass and volume are given to you. And specifically, all of our volumes were in milliliters. Today, we're going to use the same density equation, but now we're going to have volume in cubic centimeters. So how do you find volume, or how do you get volume to be in cubic centimeters? So if the volume is not given to you in the form of milliliters, you most likely have to use this calculation to complete it. So for regular shaped objects with flat sides like squares, rectangles, you're going to use the equation length times width times height. The length and the width and the height would be measured with a ruler using centimeters. So if you have cm times cm times cm, you get cubic centimeters. So that's how you can get the other volume unit. The second option, if you're not given volume, and it could be in milliliters, would be finding volume by water displacement. This is used for irregular shaped objects that you can't measure the sides using the length, width, and height equation. So in this case, you start with a known volume in a graduated cylinder. For example, 60. We know that because there's marks on the graduated cylinder. I then add the object. In this case, it looks like a screw. Irregular shaped object, I can't use length, width, and height for that. I add the screw. It pushes the volume up, and now the volume is reading 80 milliliters. To find the volume of just the screw, I take 80 minus 60, and I get 20. So the screw's volume is 20. And then mass you can find by using a balance. So let's practice some examples of actually finding volume in these different methods. All right, so first example for today. Calculate the density of a metal cube that has a mass of 6.2 grams and all sides are 2.5 centimeters. So you first have to know, what does a cube look like? I'm going to try to draw one the best I can. Okay, there's my cube. Three-dimensional, a little lopsided. It's saying all sides are 2.5 centimeters. So 2.5 this way, 2.5 centimeters that way, and I'm going to try to draw it this way, 2.5 centimeters that way. So we're doing length times width times height to find the volume of the cube. So 2.5 for my length times 2.5 centimeters for my width times 2.5 centimeters for my height. And that gives me 15.63 centimeters cubed, because I took centimeter times centimeter times centimeter 3 times. Okay, so that is my volume. I know my mass from the problem, so now I can plug it in to the density equation. So mass was 6.2 given in the problem. I had to find the volume because it was not given to me. Don't forget units. So in your calculator, 6.2 divided by 15.63, and I get 0.3, I'm going to go 97. If you rounded it to 4, that's fine. And my unit is grams over cubic centimeters, just like right here. Okay, so that's finding volume using the length, width, and height equation. Try this one. Calculate the density of a plastic rectangle whose sides are 4.5 centimeters, 6.5 centimeters, and 3.5 centimeters. The mass is 45.7 grams. So mass is there, one side, two sides, three sides, and it's a rectangle. It wants me to find density. Okay, so I'm talking about, I don't know how good this one's gonna be. Not too bad. Okay, so I've got a length. We'll say this is a 6.5, it doesn't really matter. We'll say the height was 4.5 and the width was 3.5. So it's looking something like that. Okay, so once again, I have to use length times width times height. So I'm just putting all these together, whatever order, it doesn't matter. 4.5 centimeters times 6.5 centimeters times 3.5 centimeters. And that gives me 102. This can't be right. Let me check, hold on. No, I'm right, all right. 102.38 centimeters cubed. Once again, that was my volume. I have my mass given to me in the problem. So now I plug it in, mass divided by volume, and I get about 0.45 grams over cubic centimeters. So that is using volume, length times width times height. Find that first, and then you just plug in to the density equals mass divided by volume. All right, now let's try an example using water displacement to find volume. So determine the density of an irregular shaped object whose mass is 7.5 grams and whose volume changed the reading on the graduated cylinder from 25 to 45. Okay, so what does that look like? So if we have a graduated cylinder here, and there's 25 milliliters of water, and then we add their irregular shaped object, let's say it's a random shaped rock. As I added it, the water level increased from 25 to now 45. So the water level was pushed up. So in this case, to find volume, all we have to do is take the new water level minus the original water level, and that will tell us the volume of that irregular shaped object. So it's 20, and you can never have a negative number. It's always the biggest number minus the smallest. The new volume minus the old. Okay, I know the mass from the problem is 7.5 grams. I just calculated density in milliliters. So 7.5 divided by 20, and I get about 0.38 grams over milliliters. So that is using water displacement to find volume, and then once again, just plugging in for the density equation. All right, one more example. There's a visual for you. So this says a toy dinosaur has a mass of 1.3 grams. Using the visuals of the graduated cylinders before the toy was added and after, determine the density. So we know the density is mass over volume. I know the mass is 1.3 grams given in the problem, but I don't know the volume yet. So now I have to look at the graduated cylinder. You always look at the meniscus, which is this bottom level here. Okay? And this is 4, 4.2, 4.4, 4.6, 4.8, and then 5. So my initial volume, without the toy added, was 4.8. They added the toy, it pushed the water level up. Now I'm right here. 5, 5.2, 5.4, 5.6. So my new volume is 5.6. So to find the volume just of the toy dinosaur, that's all I care about, I'm going to take 5.6 milliliters minus 4.8 milliliters, and I get 0.8 milliliters. So that is my volume. So I can plug that in on the bottom, and now I just divide. 1.3 grams divided by 0.8 milliliters. My density is about 1.63 grams over milliliters. So if I give you mass and volume in the problem, you just have to plug it into density. Or if I give you 2 out of the 3 variables, you just have to figure out the arrangement and plug them in. If I don't give you volume, you have to first determine it by either doing the length times width times height or using water displacement calculations. Then you can just complete the density. Okay, so you should now be able to complete the determining volume worksheet. That's the second for today. Let me know if you have any questions.